All right, let's dive right into this explainer and take a guided tour inside the CH-47 Chinook. If you follow military aviation at all, you already know the Chinook is the undisputed heavy-lift titan of the skies. But today, we're going way beyond the basics. We're pulling directly from familiarization manuals, technical reports, and engineering data to break down exactly how this 52-foot-long beast manages to carry staggering loads without, falling right out of the sky. So here's our flight plan for today. We'll meet the heavy lift titan, step inside the massive cargo cabin, and check out the hydraulic loading ramp. Then we'll explore the cargo and rescue winch, the ingenious triple cargo hook system, and finally, look at what keeps this aircraft at the very apex of heavy lifting. Okay, Section 1. Meet the heavy lift titan. To truly understand the engineering of the Chinook, we first really have to appreciate the staggering scale of what it can lift. 28,000 pounds. Just think about that for a second. That mind-boggling number is the internal cargo capacity of the CH-47. To put that into perspective, an empty Chinook weighs about 12 tons, yet it's engineered to swallow up to 14 tons of equipment whole. The immense thrust required to lift a payload that is actually heavier than the aircraft itself is generated by its signature tandem counter-rotating rotors. Those rotors effectively cancel out rotational torque and completely eliminate the need for a tail rotor. But it's not just about hauling dead weight, right? If we're talking about moving personnel, the aircraft can safely transport anywhere from 33 to 55 fully equipped troops into battle. And because of the aerodynamic efficiency of those dual rotors, it does all of this at speeds approaching 200 miles per hour. That literally makes it the fastest rotorcraft in the Army fleet. Moving on to Section 2, inside the massive cargo cabin. Now, stepping into the belly of the beast, let's explore how it actually manages that incredible internal payload. Inside, you're looking at a vast 42 cubic meters of cargo area. This is a constant section composed of 4 panels that is just remarkably roomy. I mean, it is roomy enough to comfortably accommodate 2 high-mobility multi-purpose wheel vehicles, Humvees, parked back-to-back right inside the fuselage. It's basically a flying garage. Section 3, the hydraulic rear loading ramp. So the crucial point here is, how do you quickly get thousands of pounds of gear, like those vehicles, in and out of that massive fuselage, especially when you're operating under fire or in a combat zone? Well, the answer is the hydraulically operated rear cargo ramp end door. It's engineered specifically for rapid, straight-in loading. You can actually stop and hold the ramp at any intermediate position, and it features a retractable door that automatically tucks right into the ramp as it's lowered. It even has a backup hand pump in case normal hydraulic system pressure is lost, which means cargo can absolutely always be deployed. And once that cargo is inside, it absolutely has to stay put. The main cabin floor itself is a total engineering marvel. It's rated for a distributed cargo load of 300 pounds per square foot. The outboard portions of the floor, the treadways where the vehicle wheels sit, are designed for up to a 2,500-pound wheel load. But here's the crazy part. The floor is packed with 87 5,000-pound tie-down fittings, plus 8 10,000-pound tie-downs. This massive web of anchor points ensures that incredibly heavy vehicles stay perfectly anchored, even during high-speed evasive maneuvers. All right, Section 4, the cargo and rescue winch. Let's move a little further inside the cabin to check out a highly versatile utility subsystem that's used for both heavy logistics and saving lives. The Chinook's hydraulic winch has this incredible dual utility. For cargo reeving, which is routing the cable system through pulleys, you can attach pulley blocks to those floor tie-downs we just talked about and mechanically drag heavy cargo right up the ramp. But for rescues, you completely flip the script. You can run that exact same cable up to the ceiling overhead, dropping it down through a dedicated rescue hatch right in the center of the cabin floor. This flexibility is all powered by the mechanics of the winch itself. The system utilizes a 2-speed hydraulic gear train. That gives you a slow, deliberate retrieval rate for hauling massive cargo and a much more rapid rate for hoisting personnel during critical rescue ops. It's also incredibly safe. It features an automatic overload limit switch that immediately stops the winch if the cable snags, totally preventing the line from snapping under all that immense tension. Section 5, the triple cargo hook system. Now let's step outside and look underneath the fuselage at the external mechanisms that truly cement the Chinook as an absolute powerhouse. This brings us to a fascinating engineering dilemma. The Chinook can carry a maximum of 10 tons externally. Now, when you're carrying massive bulk out in the open, like a downed aircraft, artillery pieces, or giant fuel bladders, physics becomes your biggest enemy. If that load starts swinging or if it's attached even slightly off center, the aerodynamic forces could literally tear the helicopter apart. So how on earth does the Chinook maintain its center of balance? The secret lies in the brilliant triple cargo hook system. There is a forward, a middle, and an aft hook running right along the belly of the aircraft. By methodically following a strict load distribution strategy, crews connect the heaviest load to the center hook, the next heaviest to the forward hook, and the lightest load to the aft hook. This precise geometry keeps the aircraft's center of balance strictly within allowable flight limits, no matter what it's carrying. For particularly unwieldy or awkwardly shaped loads, crews will actually use multiple hooks simultaneously. By utilizing the forward and aft hooks together as a dual-point load, the cargo is locked into alignment with the fuselage. This drastically reduces dangerous swinging and twisting during forward flight, which allows the pilot to safely maximize the helicopter's speed without ever losing control of the payload. Finally, Section 6, the apex of heavy lifting. To wrap up our anatomical tour, let's look at how this machine has managed to stay incredibly relevant for over 6 decades since its introduction back in 1961. The crazy thing is, while the brilliant internal mechanics, the massive cabin floor, and the triple hook system remain largely the same, the sheer muscle powering them has evolved dramatically. The original Honeywell T55 engines produced roughly 2,650 shaft horsepower. Today's current engines output 5,000 horsepower. That is nearly double the original muscle. And with the future 714-seat upgrade currently in the works, that power will push to 6,000 shaft horsepower. That's going to double the operating range for missions at maximum payload and ensure the airframe is totally ready for the next generation of warfighters. Which leaves us with this really powerful thought from our source material. When you design something that big, that versatile, that powerful, and that fast, you've pretty much reached the apex of modern aeronautical design. The CH-47 Chinook is just a masterclass in heavy lifting engineering. It's an airframe so perfectly conceived that the solution to future challenges isn't to build a new helicopter, it's just to give the Chinook bigger engines. Ultimately, how long will it be until we see a completely new design capable of truly dethroning this engineering masterpiece? I'll leave you to ponder that one. Thanks for joining me on This Explainer.